So you have idea about classes?
My classes?
Wrapper classes.
Oh no, I don't think I've used these.
The data before call a function called swap function, right? Which grab the values of a and b. Okay. done with this one. Passing pass. Before swapping, the C and D is swapping. So here the state of the object is changed, right? Ah, and I am saying that a call by value is only applicable for Java, not call by reference. But here you can see that the state of the object is changed, right? So basically, what is happening here? Ki I am passing down the object of a class, right? And whatever, and I am manipulating the variables or the instance variable present inside the class, right? And in this way I am going to change the state of the uh, instance variable of an object, right? So in this way we can do call by a reference in Java. It's not a direct way, indirect way of solving the problem for uh, call by a reference in Java. Okay, so this is how we do. So whenever we change any instance variable data by calling a method, right, and that reflects to the caller, right, so it is called call by reference. Okay, but Java uses only call by value while passing a reference variable as well, right? So it creates a copy of the references and passes them as a valuable to the method. So as reference points to the same address of the object, right?
Right.
So as reference point to the same address of the object. So creating a copy of a reference is of no harm. But if new object is assigned to the reference, it will not be reflected. Fine. It will not be reflected. But the thing is this, okay, here what is happening? Okay, as it is passed by a reference, as the objects are always passed by a reference, Java is not creating the copy. Fine. Then what will happen? Okay, it will uh, where I was. Then what will happen? It will change the information stored in the object, right? So what is happening here? You are copying the reference of A object. You are copying the reference of A object to this A object, right? And you are copying the reference of B object to this B reference variable, right? And now what you are doing, you are creating a new object, you are creating a new object and assigning the data of A, and then you are changing the data. Fine. So it will reflect into the caller because the memory is being shared by the function as well as by the caller function as well as by the called function. Right? So so this is in this way we can perform call by reference in Java. Understood?
Yeah.
So so I can write here call by reference. We can write here call by reference. Both both actual and formal parameters actual and formal parameters refer to the refer to same location. Okay, same location. So any changes made inside the function made inside the function are actually reflected in actual parameters actually reflected in actual parameters in actual parameters. Fine. This is what is happening in call by
Reference.
let me copy the code and let me copy the code here. And use it over here. And I will place the other class over here. Right. So, so what I'm doing here, okay, when I'm creating this object, so what I'm doing here, okay, when I'm creating this object here, right, when this line gets executed, right, it will create an object A, okay, and this object will contain A like this, right? This is object A, this A, right, and it is containing internally this A, fine. Then then I'm executing this line, and this line is this A is containing 30 here, right? Then I'm executing this line, okay? So this line is B, okay? And B is containing your A and this A is containing 45. Okay, then I'm printing here A dot A. So A dot A is 30, so it is printing your output. In the output it is printing A equal to 30 and is printing B equal to 45, because B dot A means this A. Okay, so now I'm calling the function swap function, right? So what I'm doing here, so I'm copying the reference, this reference. These two variables are in which function? These two variables are in main function. Okay, these two variables are in main function. But
Main function.
right. So but what I'm doing, I'm creating a function called swap function, and here here what I'm doing, I'm calling the swap function with a comma b. So the reference of a gets copied to this a. Say the value of say the address of object a is at the rate 770, right? So here in swap function there is a and it is containing only at the rate 770, at the rate 770.
0.
Address of this object is say 803. So here there is another b out here and it contains the at the rate 800. So this is how the references is being copied. What it is being copied? References. Right? 770 is copied to A, 870 is copied to B. That means that this B is actually pointing to this and this A is actually pointing to this. Okay.
Mm.
So now what I'm doing here, I'm creating an object C here, right? So
Mm-hmm.
this is object C, right? And the C is an object and it is containing 1A, right? So if you read this statement, new int wrapper a dot a. So a dot a is this a, right? This 30 is out here. So 30 is stored over here, right?
Mm-hmm.
Now you can see this statement a dot a equal to b dot a. So a dot a means it is referring to this memory area, right? Equal to b dot a. So b dot a, b means ki this b is referring to this a, right? So this 45 is copied to this a, right? Select this one. So here 45 will come, right?
Mm.
Okay. Then what statement I have written? I have written b dot a. So b dot a means it is pointing to this memory location is equal to c dot a. So c dot a data is 30, right? So 30 will be copied there, right? 30 will be copied there. Right. So now this function gets over and the control will get back to this line. Now when this line is printing, it's printing a dot a, this printing a dot a. So that means it's printing a equal to 45 and b equal to this b 30. See that the data is being swapped, right? By using call by reference technique. But the authors of Java are saying that no, Java never supports call by reference. It always supports call by value. But we can see it practically. It is supporting call by value, right?
Mm.
So, so let me write down the difference between call by value and call by reference. Let's create a table and then I will type it down. Modify table. So two columns. Let me create this one. Okay. Let us create over here. First, let me write call by value, and call by reference and call by. So here we have call by value, call by reference. So while calling function, we pass value of variable to it. Value of variables. Value of variables to it. Such functions are known as what functions are known as call by values. By value, right? Or in call by value, in call by value, we use primitive types. Yeah?
Yeah.
Data or data. Okay. Now we write on the call by reference. When while calling calling while calling of function, while calling a function, instead of pass by pass by values of variables, pass by values of variables, we pass address of variables, address of variables, or location of variables, right? To the function. We can write here about address of variables or location of variables or reference to the function, right? Known as call by reference. Right? So in this method, in this method, the value of each variable calling function copied to copied into corresponding into corresponding dummy variables or formal parameter formal parameter of the called function in this method, the address of actual value of actual variable address of actual variable is passed address of actual variable is passed to the calling function is the function are copied into the variables of called function, right? Call by value with this method the changes made to the dummy variable or formal parameters in the called function have no effect on the actual variables in the calling function. Actual variables in the calling function. Next thing is with this method, using addresses using addresses we just a minute. So with this method using addresses, we would have an access to the actual variables, and hence we would be able to we would be able to manipulate them, to manipulate. Right. So in call by value here we use only primitives, primitive data types. Primitive, yes, primitives primitive data types, and here we use objects as actual variables, actual mm, variables, or the formal parameter, actual variables. And here we use objects as actual variables, right? So here we use primitive data types, and here we use objects. Here we use objects, right? That's the difference between these two. Okay. So that's the difference between call by value and call by reference. Fine.
Right.
Mm. Um, the, the next thing is in the methods chapter. I've covered everything, I think. Parameter, return values, methods without return values, reusable method, solving stepwise, variable scope, and there is something called recursive methods, right? Recursive method is done with you people in your college or your school.
Yeah.
Okay, so it's a very easy concept, right? I can tell you the concept in only one line, right? Right? When a method calls itself, when a method calls
All
itself,
itself.
create an iteration. To create an iteration, means loop, right? Create an iteration, right? It's called recursive methods, right? To understand recursive method, you need a practice for at least 2 to 3 months.
Mm-hmm.
How to think about recursive functions. let me explain you a few things over here. Recursive. Recursive methods. So recursive methods means कि when when in the method body, in the method body in the method body, when the method calls itself itself self under a certain condition, under a certain condition, under a certain condition, all right, to form iteration or loop to solve a problem, solve
A problem.
problem is called recursion. Right, this is the definition of recursion. Right. So right here, so that is called a recursion. Here, the thing is this: in recursion, in recursive methods or in recursive methods, and the recursive methods, recursive recursive method uses processor stack stack to solve a problem. Mean by processor stack, when your program is executing, your processor stack is being used, right? So for example, in our previous code, right, in our
Previous code.
previous code, what is happening here? Okay, when this function is being called, right? When this function is being called, when this function is right, function is called here, right? Function
Yeah.
that when this function is being called, what is happening here? Okay, thus so there is a jump. There is a jump from
Jump.
this part to this part. There is a jump from this part to this part, right? There is a jump, right? So
Yeah.
what your processor will do? It will store. It will so
Store.
so when we call a method, when we call a method, right? The before jumping to the method, right? Before jumping to a method, to the method, to the method, we store the state of the method, the state of the
Method.
method in the processor's stack, in the processor's stack.
Stack.
So what we are going to store? right? We are going to store the state of the objects, right?
Mm-hmm.
So what we are going to store, we store the, yeah, I have written already. Method, we store the state of the method in the processor stack. So what do you mean by stack? Any idea, Uday? Stack, what is
Uh,
stack?
it means give me.
Have you used stack in your life?
We've been talking about it, but we haven't used it that much.
No, I'm talking
And
about
it's
in your real life. You have used it, I think so.
yeah, candy Pez dispensers from our notes.
No, I never. You always relate the studies with the real life, right? So
Mm,
stack you have used, I think, in your life, right? You have a cookies box in your life. Have
yeah,
you used cookies box in your life, right?
yeah.
So you recycle the cookie box or you throw it out when you consume all the cookies.
Usually we recycle it.
Yeah, now we recycle it. Same thing happens. I am also recycling my cookies box. Let me show you. Right. So in front of me, I have one cookie box. So I'm showing you uh, that. So I'm switching on my video so you can see it. So this is a cookie box, right? This uh, this box is containing the cookie, right? And what is happening is this box is closed on one side. This box is closed on one
One
side,
side.
right? And I can open the box from other side, right? So whatever
Right.
last cookie I have stored in the box, I can take it out, that one, right? So this is the last cookie I have stored in the box, right? So I can take out and I can consume. So again, if I have to take out another cookie, then what will happen? I have to pick the another from the top of the box, right? The cookie which is present at the top, I can pick that one. Fine. So this is the process, right? So this is the process, right? So the name of this process is called last in first out. What is the name of the process?
And is
Last in first out, right?
last in first out.
Right. Last in first out. It's called LIFO. Okay.
Hmm.
So stack uses uses last in last in first out. Last in first out method, that is called LIFO. That is called LIFO, right? So
Lethal.
LIFO, right? So that is what stack uses, and same thing is there inside the processor's stack also, right? So recursion uses this. So in the stack, right? In your stack, so in your stack, so in your stack, right? This is the
Mm-hmm.
stack. It is closed from one side. So in your stack, the main function is pushed. The main function is pushed,
Push.
and current executing function is swap function. Current executing function is swap function. When swap function is done its job, right, then it will look at into the stack, which is the top method, main method. So it will take out the main method to process, and it will process the main method, right? It will take out the main method and process the main method out, right? So processor uses stack uh, to store a to store the state of the method in the processor stack, right? Whenever we have a jump statement,
Jump statement.
right? So in recursion also we use a stack, processor stack, to solve our problem. Say for example, I need to find out, I need to find out the sum of the following series. Sum of the following series. Following series. Like I'm finding out the series like 10 plus 20 plus 30 plus 40, like that, right? Until n terms I need to find it out. So how I will write this method, right? So let me show you. So if I'm writing here int, um, series, I'm writing here integer of n. So n is basically number of terms, right?
Mm.
What so what I will do here, and I need I need another value here. The value, the start, the starting term, right? Starting term. And int. Then this function will return me the sum of the series, right? So what I will do here, I will write here if 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 n is greater than 0, right? So I'm writing here return start plus sum of sum of series sum of series, right? And I'm writing here n minus 1, writing here n minus 1, and start plus 10. Okay, and then here in the else part I'm writing return say say return n. Okay, and let's see how this works, right? So, so if you want to do the dry run of this function, what you have to do, say I'm assuming that key the value of which is a color. So I'm assuming that the value of n is the value of n is 5 and the value of start is 10. Okay, so this function is being called, and now the value of n is greater than 0, right? So it will call here start, right? So the value of start is 10, right? Plus again the function is being called. The function is being called, right? The function is called sum of series. What is n minus 1? N is 5. 5 minus 1 is 4. Right? The value of start is 10. So 10 plus 10 is 20. This function is being called like this, right? So in the stack, I am saving this state. Okay. So I am saving this state. Clear?
Clear.
This is saved in the stack. Fine. So now, so this part is saved in the stack. This part is saved in the stack. Now there is again the function call is there, right? So again, I'll having here start. Let me write here start. Uh, Let me write here start instead of 10. And then it is start. Right. Now there is a function call again. Again, n is 4. 4 is greater than 0. And again, this is statement executed. So again, here the value of n is equal to 4 and start equal to 10. And here the value of start is equal to 20. Right. And again, the same thing happens here. Start plus sum of series, right? And 4 minus 1 is what? 4 minus 1 is 3. And 20 plus 10, 20 plus 10 is what? 30. So this will be saved in the stack because this function call is there, no? This function call is there. Now again the function is called. So n is equal to 3 and start is equal to 30, right? Right. Let me reduce a bit of size. It's visible to you, right?
Yeah.
Okay, okay, fine. So n is equal to 3 and start equal to 30. So again, I have the same thing. This condition is true. It will call the value of start and plus uh, I have to write here sum of series, sum of series, and here I have to write the value of n will become 2 and this will be 40. This will be 40.
40.
Right? One thing I can do here instead of returning n, if I can write here, I can write here start. Okay. And instead of returning 0, I can write here 1, right? So I will save one execution time. Let me use this red color. Loop of fine. So again there is a function call, right? Again there is a function call. Okay. So here create more space. So again I will write here n equal to 2 and so 2 is greater than 1. So the value of and the start is 40 and the value of start here start plus the sum of series series and here 2 minus 1 which is 1 and here we have 50 out here, right?
Mm.
we have done completed this much, fine. So again there is a method call, right? So here now the value of n equal to 1 and start equal to 50 and start equal to 50, fine. So
Mm-hmm.
1 is greater than 1 is false, right? So what it will do, it will execute this return statement, right? Return start. So what will happen here? This return statement will execute, right? Return start. So start means 50, right? So 50 will be returned. So this start will be returned to the last call. The start will be returned to the last call means over here, right? Let me change the color of this. So the start will be converted. Instead of this statement, instead of this statement, 50 will be replaced. What will be replaced? 50, right? And we know the value of start here, which is 40, right? Got my point, Uday?
Yeah.
So 40 plus 50 is what?
40 plus 50 is 90.
So this box will return you 90, right?
Mm-hmm.
And this 90 will be replaced over here. This whole thing will be replaced by 90. Okay. And the value of start is 30. So 30 plus 90 is what?
30 plus 90 is 120.
120, right? And then this 120 will be replaced by this, right? So this is 120 and the value of start is 20. So 120 plus 20 is what? 140,
120 plus 20 is 140.
right? So 140 and then this 140 will be returned to this point, right? So here this statement will be replaced by 140 and the start is replaced by 10. So 10 plus 140 is 150, right?
Mm.
This whole thing results to 150 and 150 will be returned to the caller. We returned to
One, the color.
fine. So the person who is calling or the function which is calling this method will be returned to it. Understood?
Mm.
So how many loops have formed here?
4 or 5.
Oh no. Oh, one loop is for storing the data into the stack, right? And one loop is formed to releasing the data from the stack. So there are two loops. There are
There are 2 loops.
two loops. One loop is for pushing the data. Now, this is one loop. We are inserting data. We are inserting data into the stack, right?
Right.
And there is another loop for extracting the data, right?
Mm. Right.
Right. So how many loops are there? Two loops, right?
2
So
loops.
for five, to solve for five number of terms, how many steps we will need? We will need one, two, three, four, five. Then returning is also one part, six, seven, eight, nine, and 10. So we need 10 steps in recursion. In recursion, we need 10 steps, 10 steps to solve this problem, solve this problem. Got my point? Right?
Yeah.
But if you use loop, then this problem will be solved by only five steps. If you have written this statement like, if you have written function like this for int sum of is integer of 10, comma integer of start, and you created a loop here. You have declared a variable called sum, uh, integer of s equal to 0 or sum, and then you have written here for n greater than 0, written here s plus s start. have written here n minus 1. Then return the success. Right. So it will take only 5 steps to solve the problem. So we can conclude that recursion recursion this
Mm,
takes more number of steps. Number of steps. Right.
right.
And and it forces
Forces.
the processor perform perform more tasks.
Mm,
Right.
right.
So my question is this: then why a recursion concept is there? So and it's taking more time. It's giving overheads to processors, right? Basically, it's a headache for a processor if you're solving a big problem, right? Because processor has to work
Right.
hard, right? It uses the processor's cache memory also to store the information in the stack, right? Then
Mm,
why we use recursion?
right.
So it's better not to use recursion.
Mm, okay.
Now,
Yeah.
till now, you've got the whatever idea you've got. Now, you feel that "Arey, recursion is such why we are using it, right? I asked this question to one of my students few weeks back, right? Um,
Right.
I told him his name is Akash. He studies in Georgia Tech. So he said to me, "Ki, Sir, recursion is slow, and this is then why we study recursion." He said it's given in the book, textbook. So I've told him, ki, no, that's not the right answer. So we use recursion because it solves very complex problem very easily. First point is we use recursion because we use recursion to solve complex problem, complex problem
Mm,
very very easily. Right?
right.
So this is the first point. Second point is that we can make recursion faster. Make recursion faster. Recursion. By supplying uh, additional variables, additional variables, and additional variables to its parameter list. To its parameter. So this is how we can make the recursion faster. There is a way also, right, to make the recursion faster. But the main problem is this key thinking in a recursive way. It's very difficult because we are always thinking in the form of loops, right? So it's a bit difficult to think in a recursive way, right? Because in our future we have to study recursive data structures, right? So we need to use recursive data structures, recursive data structures, which is like we have to use something called tree, right? Tree is a recursive data structure. There is a You have studied, I think so, in your this semester also. They taught you binary tree.
Yeah.
Binary tree is a recursive data structure.
Mm.
There is another concept called graph. Graph is a recursive data structure. There's another concept called hashing. Is a recursive data structure, right? There is a concept called map, right? Is the
Mm.
recursive. There's a concept called dictionary. Dictionary. Dictionary is also a recursive data structure, right?
Mm.
Dictionary spelling is correct.
Yeah.
So these data structures are recursive in nature, because if you don't use recursion, then you are in trouble. If you use loops to solve the problems of tree, graph, hashing, map, or dictionary, then your code will increase its size in such a way that you cannot control, right?
Mm.
So you have to use recursion to solve the problems of these data structures. So recursion is a nice technique, and you start solving problems using recursion. Fine. So let me show you this program practically how this is working. Right?
Mm.
I'm writing here. So I'm writing the name series. Get this function over here.
What are you doing?
Yeah, number of terms, and we have another parameter here at the rate and start the first term, the it represents the first represents first term, yeah, it's the first term. Control S. See here, they have written here n number of terms and start it represents the first term, right? So that they have generated the Java documentation, right? Have to write this. So you can you can use this at the rate param, right? To write the details about the parameters, and this kind of documentation you need to generate whenever you are writing a project in Java, right? So here I'm writing and then I'm writing enter number of terms in n, and I'm writing here enter the first term term in start, right? So control K, and now when I am executing this method, right, you will see that it is written here in the dialog box, enter number of terms and n, and enter number of first term and start. So it's very easy to understand what this method is doing, right? So now I'm writing the rest of the code here. I'm writing here if n is greater than 1, right? And then I'm writing here return start plus sum of series I'm writing here n minus 1, and I'm writing here start plus 10, right? Every time this happens, and then I'm writing here return. So I'm writing here else, then I'm writing here start, control K, control W. So now you can see that, okay, I'm writing here 5 and I'm writing here 10. Now you see that the result, so result is 150, right? So it has returned me 150, and I can call this function from here also directly. I'm writing here series, right, dot uh, sum of series. I'm writing here 5 comma and 10. Okay, so I need to print it on the terminal window. So I will write here system dot out dot print ln. Then I will write here slash f sum of series, right? So it will print the sum of series in the terminal window. You can see that, right? We can execute our experimental codes like this in Java. So it's quite handy to do experiment in bluejay, right? Understood, Uday?
Yeah, I think I understand.
You can see the code here. If you have any question, you can ask me.
That's fine. I've been looking. I've been working on similar stuff. So
Okay, fine. So, Uday, can you write down a code for me? Right, I'm telling you, I'm writing the question here. So you have to write the recursive function for me. Right, I'm just writing down the recursive function. All right, program to input number and uh, reverse its digits, its digits, digits, right? And here you cannot use, cannot use string to solve the problem, right? So your method will look like this: public. You can use a static also, and you write your int, right? And then here you can write reverse of digits, reverse of digits, and here you can write integer of say n, right? And you can write down the function. And here I am going to give you one facility that you can increment number of parameters. You can you can write you can use more number of parameters than this one if you want. Okay. This is I use more than this parameters also. You can use more parameters. You can use more parameters. But this one is compulsory. But this one is compulsory. It's visible, right? My handwriting is visible or readable,
yeah.
right? Okay, fine. So you copy this and you share your screen and solve this problem.
Okay. What was the thing you were showing again? Public static int.
Public static int reverse of digits,
Int.
integer of n. No, reverse of digits is the name of the method. It's correct. Don't delete it. Just delete the brackets now. Just delete the bracket. Right. Reverse of digits in the bracket. You in the bracket you type integer of n.
saying missing return statement.
Yeah, that's fine. You write your idea.
And the point of this is to reverse its digits, right? So,
Right. If you enter 1, 2, 3, it will give you 3 to 1.
And this is just ideas. I don't have to code anything until later.
You have to write your recursive idea inside this method. That's it. You don't have to write
Okay.
main function.
Raj, what are you doing?
They're there for you.
Wait, why are you laying out? What do you mean by that?
I mean, that dinner's waiting.
You could have just told me that instead of running into here.
Uday, here we are not going to take any input from
No,
using scanner,
no scanner? Okay, I'll get for that.
because we assume that the input is already made.
Oh,
in
so
n.
instead of having an integer, we would just have n is equal to some number.
Yeah, n equal to some number, right? N maybe any number.
You said don't put any code, right? Or should I try something?
You just write your idea.
Okay.
You can use symbols instead of using words. Just doesn't equal to will be not equal to symbol like that.
I remember doing a problem like this in one of my computer science classes. Though don't remember if it was this one or last semester's. How is this?
So reverse of digits should be multiplied with 10. No, reverse of digits multiplied with 10 plus n modulus of 10. Achha, you have done it already. Fine. Fine. Okay. And then you are adding the modulus value with it. Okay, that's great. And yeah, so using this idea, we can solve the problem, right? So I'm sharing my screen and I'm using your idea to solve the problem. Okay.
Okay.
Fine.
Or wait, should I keep it up?
Yeah, you keep it up. Not a
Okay.
problem. Keep it up. See this. I'm writing here. So I have a class here already present, number theory. So I'm writing one function over here. Like say integer ERSE reverse of digits, and passing a number here, integer of n, and from here I'm calling a function, right? Return reverse of digits, reverse of digits. I'm passing here n and I'm passing here 0. So I'm using a concept here called function overloading, which, right? So I'm writing here private int reverse of digits, and I'm writing here integer of n, and I'm writing here integer of say r. So now I'm going to write here if n is greater than 0, if n is greater than 0, then what I will do here, I will write here r equal to r multiplied by 10 plus n modulus of, right? And then I will call the method, right? I will call reverse of digit n by 10, and I will call this r. Okay, so, and I will write here return return, and when n is 0, then I will write else. I will write here return r. Okay, so here in this way I can reverse the digits. So let's compile this code and try to execute this. So new number theory, I've created the object, and number theory has the reverse of digits. So I've entered here. So now I've entered here 6758. Okay. So I press the enter key and it has reversed the digit 8576. Fine.
Come on.
So here I'm covering something called function overloading.
I already ate my dinner.
Really, Raj?
Mama calmed me down, and since you're busy with work, you go down. Sorry,
Okay.
babe.
So let me explain you this here. Slowly, right? So what I'm doing here, okay, I've created this method, right? Public int reverse of digits, integer of n, right? So this method is public, right? So it is visible to outer world. So this method is visible to outer world. Right? And this method is private. So it is not visible to the outer world. Right? Not visible to the outer world. Right? Okay. So if you can see that in BlueJ, right? In BlueJ, when I'm right clicking on this object, you can't see that method. It is showing only 3 methods which are public, right? Private method is not being shown here, right? So how I am solving this problem, people don't understand. Means how I'm doing it. The method is hidden, right? You can think about Chinese people. They solve problem like this. Okay. So this process is hidden here. So actually, this method is solving the uh, problem and returning the information to this method, and this method is sending the information to the outer world. Right? So it gives you the more security of your how you are solving the problem, because the hacker can see your public method. Hacker cannot see your private methods, right? So this is the way we can provide security, and you can understand here the concept of function overloading, right? Function overloading. So in function overloading, in function overloading, loading, the name of the method, the name of the method is same, but it differs with number one, number of number of parameters, and number two is if number of parameters are same. Number two, if number of parameters. Oh, would you be able to see my screen?
Not really.
Okay, let me show you my screen. Actually, you have to tell me, right?
I thought it was intentional, to be honest.
Okay, it's fine. So now the screen is visible, right? I have written this a public int reverse of digits int n and return reverse of digits n comma 0, and then I have written a private method private int reverse of digits integer of n comma integer of r, right? If n is greater than 0, then r equal to r into 10 plus n modulus of 10, right? And then I've returned reverse of digits n slash 10 comma r, and in the else part I'm returning the value of r. So this r will be returned to this, right? And this is returning to the outer world. This is returning to the outer world, right? So this function is private, so it is not visible to the outer world, and this method is public, so this method is visible to the outer world. So when I go to BlueJ, and I am doing the right clicking on this, you can see that it is displaying the int reverse, but it is not displaying the next function, right? So you go to I have written this function in class called number theory, right? Where is number theory? Yeah, this is a number theory. Okay, so you can see this method. See here, I've written this, right? And I have written this also over here. Now I'll show you how this is executing, right? So when I'm right clicking on it and I'm clicking on this function and I'm entering information like this, and it is returning the value. See, so 7864 I have entered and it is returning 4678. So it is reversed. So the number is, so digits are reversed here. Okay, so I'm showing you there's another concept called function overloading in functions chapter, right? In function overloading, the name of the method is same. The name of the method is same, but it differs with number of parameters. And number 2 point is if number of parameters is same. If number of parameters is same, then it must differ with data types. It must differ with data type data types of the parameters. Fine. So this is the thing about function overloading. Now you can see that in the first function, I have only one parameter. How many parameters? One parameter. But in the second function you will having how many parameters? Two parameters. So it is using the rule number one, right? It is using the rule number one. So here we are passing two parameters n and 0, right? So what I am doing it internally, right? So a person cannot see what I am doing and how I am solving the problem here, right? So let me explain you how I have written the logic of this function, the private function. Okay, so let me copy this part. So I need a full page to explain you. So I'm copying it here. Control V. So now the value of n, say the value of n is 4, 5, 6, 3. Okay, and the value of r is 0. value of r is 3. Now this, now I have tested this condition, right? N is greater than 0. Okay, so condition is true. So here what I have done, I have written this formula r multiplied by 10 plus n modulus of 10. So the value of r changes to 3, right? Now what I'm doing here, I'm writing here return reverse of digit n by 10, right? So I'm calling a function reverse of digits n by 10. So n by 10 means कि I'm calling this function once again. I'm calling this function once again. Uh, I'm calling this function reverse of digits, digits with 456 because n by 10 is 456, right? Comma 3. I'm calling this function in this way, right? So as there is no due statement here, right? As there is no due statement, it will jump to the next part, right? Again here. So n is equal to here 456, 456 and r is equal to 3. Now you came down, n is greater than 0. So the value of r is 3 into 10 is 30, 30 plus, and you will get here 6. N modulus of 10 is 6. Correct, Uday? Correct?
Yeah, that sounds correct.
Right. 3 into 10 is 30 plus n modulus of 10 is 6. Right. So total result will be 36. So the value of r will be 36. Right. Fine. So the value of r will be 36. Clear? So now again the function call. So reverse of digits, right? So here we have 456, right? So 456 by 10 is 45. Fine. And here you are passing 36. So in the next step, what I'm doing here, uh, here, so in the next step, what I am doing here, k, I'm writing here, n is equal to, so here what I'm doing, I'm writing here n equal to 45. Fine. So the value of r is 36. Fine. And then you are writing reverse of reverse of digits, right? Reverse of digits. You will write here 45 by 10. Sorry, I missed it out. Uh, so I got 45 and 36. So 45 and 36. So the value of r is 36 here. So 36 into 10 is 360. 360 and 45 modulus of 10 is 5. So 360 plus 5 is how much? 365, right? So what will happen here? Okay, here you will get 4 and in R you will get 365. Fine. So this will be forward over here and the value of n is 4 and the value of R is 365. Now again you go back and there is a function call. The value of n is 4. So 4 is greater than 0, right? And the value of r will be 365 into 10, that is 3650 plus 4 modulus of 10 is 4, so 3654. So this value will be 3654. Wait, let me write this as 365. It was 36 converted to 365. So 3654, right? And then you call the function reverse of digits, reverse of digits. If you write here 4 by 10 is 0, 4 by 10 is 0 comma 3654. Now this will go to this part, right? The call is go to this part. So the value of n is 0 and the value of r is 3654, right? and what will happen, n is greater than 0, so this condition is false. So it will come to the else part, it will come to the else part and it will return the value of r. So return r, right? 3654, right? So as there is no due statement, this value will directly be returned, right? As there is no due statement meant for calculation, right? This value will be returned directly to the caller. This value will directly return to the caller. Return to the caller. Fine. So this value will be returned to the this function. This value will be returned to this function. Let me copy it also. So this value will be returned to this function. So this value will be returned to this function. Yeah. So this value will be returned to this r will be returned back to this r will be back to here, right? R will be returned over here. So instead of this r is there and this r is returned to the caller. This r will be returned to the caller. Sorry, what I'm writing. Return to the caller. Uday, it's fine. It's understandable.
Yeah, it's understandable.
Okay. Actually, suddenly a person came in my room and I got it disturbed. So, it's fine for you, right?
Yeah, it's fine.
Okay.
For me.
So this is the recursion, and you need to practice it in a regular basis. Fine. So you can practice to find out the prime numbers using recursion. I have done loads of problem using loops, right? You try to convert those problems in recursion, and as you have always submitted your work, right? So this week I'm not giving you any work. So what you will do, okay, you convert or try to convert all the functions or whatever functions you have written, right? You try to convert all the functions used to recursion, right? Such that your recursion concept will be clear. Okay. Or you want some work directly from me?
Either is fine, really.
Either is fine. Okay. Okay, then I will give you the work. Okay. So I will be giving it. I will be pasting the questions over here, and then you have to write the solve the questions using recursion. You are not supposed to use any loops.
Okay.
Okay. So you can use this technique also, which I have shown you by writing another function in a private form. And this is a very nice and very good professional techniques, and it makes your program more secure also. Fine, because the hacker can know your public methods, but hacker will not know your private methods. So in public method, he will be unknown. He is passing only one parameter, but internally what I am doing, he will not know, right? So it's very right way of writing computer programs, right? And you understood the concept of function overloading also, which I have done. Hello.
What?
Function overloading you have understood.
Yeah.
Okay. In your college, they have written function overloading concept. They might be have done with the finding out the areas of circle, rectangle, right? This kind of thing they have done. Area of rectangle, area of square, like that. They have done it in that way. Fine, because of name of the function is same area, and but you are finding out the area of a circle. You are finding out the area of a rectangle, right? Like that they have explained it, but I have done it in a different way because I missed out this topic. Okay, fine. So I'm sending you this note with the homework in an hour. Okay. So you revise this and you see this video once again also. Fine. Chalo then.
Okay.
Bye.
Bye.
I see you next week.